Section 12.1, this is part 2 on using series. Whenever you see the word series, you should just think sum. It's the same thing. You're taking the sum of a sequence of numbers. So there's this new notation, and it's called, the word for it, when I do this funky symbol, it's fun to draw, it's called sigma, or you might see summation notation. So that's how you identify it. It's called sigma, or sometimes it's called summation notation. And the symbol for it goes like this. We'll start with example number 1. So here's examples number 1. We'll just get right into it. Oh, it's going to say, the directions are going to say, find the sum of the series. Find the sum of the series. So it'll go like this. Okay, you draw this. This is your sigma notation. It's a funky little symbol that goes like that. And you're going to go from it. This is just an example. This example says go from I equals 1 to 4. That's an index. You use these in computer science a lot when you're programming. If you want to loop through something 4 times, you set I equal to 1, and then you say I plus plus each time, and you go all the way up to 4. So this says do this 4 times, and the expression is 2I, and that's all you'll see. It's very symbolic. So that's the question. It says find the sum. So but watch how easy it is. What you do first is you write out what it means. So you plug in 1 into the expression. 2 times 1 is 2. But since it's series, you put a plus symbol after it. And now I is 2, the next iteration. If you plug in 2 for I, what do you get? 4. Now plug in 3, you get. And the last one, because it says go from 1 to 4, is 8. And so your answer to the question when it says find the sum is to add up these numbers. 2 plus 4 plus 6 plus 8. 6 plus 6, 12 plus 8 is 20. And that's the answer. Let's do another one to make sure we got the notation down. And then I'm going to give you the formula for what if I'm asking you to go up to 100 numbers, and they're all consecutive. I'm going to show you a shortcut. So let's try this one. Now you don't always have to start at 1, by the way. So let's try, and the index might be anything like k. K equals 3 to 7 of k squared minus 1. That's the problem, and we're going to write it out and find the sum. So first we plug in, we don't start with 1, you start with 3. So 3 squared minus 1 is, you can do it in your head, 8. Plus, now we go to 4. 4 squared minus 1 is 4 squared minus 1, 15. And then k is 5. We get 24. K is 6. K is 7. Yep. So if you add those up, feel free to use your calculator. You will get 130. Okay, so any questions on this notation? Now, what if we say, oh, let me do this. Let me do a really, really quick one. Let's say it looks like it's going to be hard because I'm going to go from I equals 1 to 34. Oh no, I have to write out 34 terms, but the expression is 1. Yeah. Number 3, 4, 5, 6, 7. There should be 5 terms because you started at 3. Yeah. Look at where your starting index is. So this one's going to start at 1 to 34. How many terms in the expression is 1? What's the answer? You guys know right away? What's the answer? Do I need to write it out? All right, let's write it out. you plug in I is 1, but there's nowhere to plug in anything. So it's just 1. What's the second term? 1. What's the third term? Yeah, so you would just dot, dot, dot. The dot, dot, dot is, I don't feel like writing out the rest. So the answer is 34. Now, let's try, the last one is going to be something that Gauss's formula is going to help us solve quickly. So let's say I want to add the numbers, let's use the symbol n. N equals 1. We're going to go from 1 to 200, all right? I want to add all the consecutive numbers 1 to 200, and the expression is n. Okay, so we don't want to go 1 plus 2 plus 3, right? We're being asked to add all the numbers from 1 to 200. So we're going to use the formula, we're going to use Gauss's little trick. So the sum, this only works when you have consecutive integers. The sum of the first n terms, S sub n, is going to be n over 2. Remember how it was 50 terms? Like if there's 100 terms, we would use 50. And then times n plus 1, because remember how we kept adding up to 101 when we kept pairing up the first and last term and second to last. This is the formula for the sum of n consecutive integers. So let's try it on this. So what would it be in this example? What's n? N is, we're adding the numbers 1 to 200. So n is 200. So 200 over 2 times 200 plus 1. That's going to give us our answer. So we would do 100 times 201. Because if we used Gauss's method, if you added the first and last term, 1 plus 200, you would get 201, right? 2 plus 199 gives you 201. 3 plus 198 gives you 201, and there would be 100 pairs of that, right? So 100 times 201, well, we're just going to add 2 zeros to the end, and there's our answer. So our answer is 201 with 2 zeros. So it's going to be 20,100. 20,100.